Hi, my name is Tom Heffel, and this channel is all about helping students learn chemistry. In this video, we're going to do some practice problems on how to calculate the enthalpy change of a chemical reaction. There's going to be a couple parts of this. The first part is to calculate the enthalpy change, and then after we calculate the enthalpy change, we're going to go through these three sample problems, okay, and how this is different than the last video. In the last video, I only dealt with things that had mass, like it was in grams, okay? Well, question 2 is going to talk about molarity, and question number 3 is going to talk about it when it's a gas. Okay, so the first part is we're going to have to calculate the enthalpy change for this chemical reaction. So what we have to do is we have to look up the enthalpy change to produce each of these chemicals, and we do that by using our textbook, okay, or some type of appendix or values that have thermodynamic values on them. So I'm not creating these numbers off the top of my head. They're coming from the textbook, okay? So for elements, it's going to be 0, okay? So we have an element here, and we also have an element over here. So both of those are going to be 0, but the compounds we need to look up. And when I look up HCl, I have to make sure I look up HCl that's aqueous. It can't do the gas or a solid or a liquid. It has to be the one that's aqueous because this chemical reaction, the state of matter is in the aqueous form, if you will. It's a solution, okay? So when I look up that value, it comes up to be negative 167.2 kilojoules. Of course, since enthalpy is an extensive property, I'm going to have to multiply it by 2 because in this chemical reaction, there are 2 moles of hydrochloric acid. And then I'm going to look up the value for magnesium chloride. The value for magnesium chloride is negative 641.6 kilojoules. And what I'm going to do is I'm going to use that reaction or that equation where we sum up the reactants, okay? And summing up the reactants should be pretty easy since this is a 0. It's just 2 times negative 167.2. So that will come out to be negative 334.4 kilojoules. And the same thing over here, I'm going to sum up the products, okay? And the products should be pretty easy because this is 0 and I'm not multiplying this by anything. So it's just the negative 641.6 kilojoules. And then I'm going to do the products minus the reactants, okay? So to calculate the enthalpy change of the chemical reaction, it's the products, negative 641.6 kilojoules, minus the reactants, negative 334.4 kilojoules. And remember, when you subtract the negative, it's kind of like adding, okay? So, but when I put this together, okay, to 3 sig figs, I'm just going to leave it as 307 kilojoules. If you want to do negative 307.2, that would probably be a little bit more precise, okay? So we now know that the enthalpy change for this chemical reaction, so I'm going to remove the question mark, and I'm going to put this negative 307 kilojoules in its place, okay? And that's the enthalpy change for this whole chemical reaction, okay? And my questions on the left-hand side of the board are not for a full chemical reaction. Like this 1.20 grams is not a full mole of magnesium, okay? This 35 milliliters of 1.81 molar hydrochloric acid is not 2 moles of hydrochloric acid. So if we have a portion, okay, of the chemical reaction, then we're going to get a portion of the enthalpy change. So we're not going to get the full 307 kilojoules of energy being released unless we dealt with the full chemical reaction. So we're going to talk about how we handle each of these parts, okay? So question number 1, okay? What would the enthalpy change be when 1.20 grams of magnesium reacts? So I'm going to use 1.20 grams of magnesium as my given. And the first thing I'm going to do is I'm going to convert it to moles. I'm going to convert the grams of magnesium over to moles of magnesium, okay? And the molar mass for magnesium is 24.3 grams per mole. And I get that number off the periodic table. I am then going to convert the moles of magnesium into energy using the information that I just calculated. it tells me that 307 kilojoules of energy is going to be released. So negative 307 kilojoules of energy is released when 1 mole of magnesium reacts. Now, this is a portion of 1 mole, so let's go ahead and figure this out. 1.20 divided by 24.3 will tell you how many moles you have, okay? And then multiplied by negative 307 will tell you that there's an energy change of negative 15 kilojoules of energy that's released when 1.20 grams of magnesium reacts. Because I didn't have the full mole, I don't get the full amount of energy being released. Okay, so since I have a portion of a mole, I'm getting a portion of the enthalpy change. So only 15 kilojoules are going to be released when 1.20 grams react. So let's go ahead and put that answer in. That answer is negative 15 kilojoules. Let's move on to the next question. Okay, the next question says, what if 35 milliliters of 1.81 molar hydrochloric acid reacts? Well, now we're talking about a solution, but the same thing is true. What I'm going to try to do is I'm going to try to get that information into moles. Now, to do that, I'm going to use the molarity equation. So whenever you have a solution, a lot of times you're going to use this molarity equation. And I'm going to do some cross multiplication that tells us that moles is equal to molarity times the volume. The molarity is 1.81. And I can use big M or I can use moles per liter. Now the volume that I have to put in here has to be liters if I want the liters to cancel out. And right now I have 35 milliliters. So I got to convert these 35 milliliters into liters. And I do that by dividing by 1,000. So 35 milliliters is equivalent to 0.035 liters. And as you can see, I have liters as a numerator and liters as a denominator, so they cancel out, which tells us if I take 1.81 and I multiply it by 0.035, that's going to come out to be 0.06355 moles of hydrochloric acid. So this amount of hydrochloric acid is equal to this amount in the unit moles. And then I'm going to finish the problem by converting the moles of hydrochloric acid into energy according to what's up here. Okay. Now remember, 307 kilojoules of energy is released when how many moles of hydrochloric acid reacts? It's based on 2 moles of hydrochloric acid reacting. So be careful. You do have to follow these coefficients down here when you're converting the moles to energy. Okay, so 0.06355 times negative 307 divided by 2, that will give us an answer of negative 9.73 kilojoules. So when this amount of hydrochloric acid reacts, you're going to get this portion of the 307 kilojoules. Only 9.73 kilojoules of energy is going to be released. Remember, sometimes I don't say that negative number because that negative number actually just reminds us that energy is being released. There's really no such thing as negative energy. This negative sign is only telling us the direction that the energy is flowing, and it's flowing out of the chemical reaction into the surroundings. Okay, so the first problem dealt with mass. The second problem dealt with the solution. This third problem is dealing with a gas. Okay, so we dealt with solids, solutions. So solids, solutions. Now we're going to talk about gases. And what this problem is saying is, hey, a certain amount of hydrogen is being produced. Okay, and that hydrogen has a pressure of 1.1 atms. The volume of that gas is 2.4 liters, and the temperature is 298 K. Okay. Well, we need to take this information and get it into the unit moles. In fact, that's what we've been doing every single problem. We just convert that information into moles, and then we use our chemical reaction to convert the moles into energy. So in this case, since we're dealing with a gas, we're going to be using the equation PV equals nRT, and we're going to be solving for moles, which is the variable n here. So we're going to divide by RT on both sides. So moles is equal to the pressure times the volume divided by R, which is the ideal gas constant, times temperature. And this is something that we did in a previous video. So if you need practice at that, please go back and look at the gas laws and video on how to calculate this type of information. So the pressure, 1.1 atm. Volume is 2.4 liters. R is 0.08206 atm liters over mole Kelvin. And like I said, if you don't know this information, you need to go back and watch that gas law videos, okay? And then the temperature is 298 K. And if we plug this information in, we'll figure out how many moles of hydrogen there are, okay? And when you plug that information in, you get 0.108 moles of hydrogen. And all I'm going to do now is convert those moles of hydrogen into energy. And there's negative 307 kilojoules of energy that's released for how many moles of hydrogen? That's going to be per 1 mole of hydrogen. So 0.108 times negative 307 is going to give us an answer of negative 33.2 kilojoules. Okay, so I hope these practice problems were helpful to you. If they were and you found this information useful, please give it a like and subscribe. When you leave a comment, that really pushes this information to other students that are interested in learning chemistry.